Hello, everyone. Thank you so much for the amazing intro. My name is Austin Akers, and today what we're going to be doing is we're going to be learning how to build out decentralized apps. And again, thank you for the intro. So I guess I don't really have to talk much, but I'll just gloss over a lot of different things. I'm a husband and also a dog dad. So we have a little, my wife and I, we actually been married for a little over a year now, actually. So it was really interesting having a COVID wedding, or a wedding during COVID. The wedding did not have COVID, but yes. I'm also a software engineer. She said a software engineer too at Microsoft. I'm also, fun fact, I'm a break dancer, so I'm a b-boy. Yes, I can spin on my head. There are no bald spots yet. I'm also a cellist. I also do Muay Thai fighting, and I'm also an open source contributor. So I contribute to various different projects. Primarily, one of the ones I've been really recently and really actively contributing to is MetaMask. I'm not sure if y'all have heard of that. If you haven't, it's an Ethereum wallet. And ironically, fun fact, we'll be using that today. And I've also done contributions to Vue, Vue Router. So yeah, I've done contributions, I think, with Vue Router 4, the next iteration. That was, and then also Vuetify as well. So yeah, there's that. So just as a quick overview of this presentation. So, I was just going to do a lot of slides, and I thought to myself, you know what, why don't we try to build something? So we're going to have some fun today, and we're going to build out a very basic decentralized app. Okay. I say, basic, quotations, because everyone has varied levels. So, but as I said, I'm going to try to reach everyone, all the different levels, and we're going to have fun today. So if you haven't already, go ahead and visit this link. What this will take you to is it'll take you to this lovely repository here. And the cool part about this is, and I'll go ahead and zoom in as well too. All right, let me know if anything's too small. The cool part about this is that we'll have a start and a finished folder. Okay, so this is where we're going to start, and hopefully by the end of this, ours is going to look somewhat similar to the finished. All right. So and for individuals who just honestly, just as I said, who may not make the meetup or whatnot, again, like the whole start and finish is just something I thought would be really nice. So if you haven't already, please clone this. So if you're not sure how to do that, you can either download the zip, or you can copy this link and do something. You can command line and type in git clone, right? I would say code spaces, but I didn't test this out in code spaces, so don't heed my advice and try to use that. Now, once you have that cloned, what we'll do now is we are going to go ahead, and it should look something here. Give me one moment. So if we take a look here, once we have that cloned, what we'll do is that we'll have an entire, we'll actually go inside and we'll open up VS Code to our DApp present, or this whole DApp presentation folder, okay, which is where our finished and also our start folder is going to be. All right. So once we clone this, what we're going to do now is we're going to go ahead and we're going to step inside our start folder, okay? And we're going to go ahead and do this. We're going to crack this open. And what we're also going to do is we're going to open up our terminal. All right. So we're going to also have our terminal go inside our, as I said, our start, inside our start folder. And then from here, what we'll do is we'll do a yarn install. Now you could do an npm install, whichever you prefer. There's a package lock and also a yarn lock specifically for this. I've already done a yarn install. Again, it could be an npm install as well. No worries. Just make sure you have Node downloaded. And from there, what it'll do is that it'll download some dependencies. And, while that's downloading for a lot of different people who are cloning this, if you haven't already, we're going to dive in a bit and just better understand the dependencies that we'll be using today. Now, back to this right here, what we'll take a look at. Oh, I totally forgot about the let's begin. Wow, the fun part. So what we're going to do here is that we're going to be working with a few different dependencies that we've gone ahead and installed. So what we have here, right? We have several dependencies. One in particular, as we'll see here, we have something called hard hat, right? And if you aren't familiar with what hard hat is, which I don't expect a lot of people here to be familiar with, hard hat is what we're going to be using for our Ethereum development environment. And the cool part about this is that hard hat allows us to be able to run tests. It allows us to be able to interact and as I said, and find bugs within or have errors and whatnot, find bugs within our smart contracts. And we're also going to be able to run a local, our Ethereum network, like locally, right? So we'll be able to run something local. And then last but not least, or whatnot, if we take a look at this again, not only will it compile and do all the fun stuff, we'll also be able to do some Solidity debugging. And if you aren't familiar with what Solidity is the language that we use to write smart contracts in the blockchain world, right? So whenever you hear of smart contracts, most of the time you can more than likely think of Solidity. All right, that is the language that a lot of a lot of engineers in the blockchain space use. Okay. Next up, we have another dependency. That other dependency is ethers, right? And what we'll be using ethers for primarily is, I've actually used this a lot. This is actually what we'll be using for the front end, right? So this right here is what we're going to be able to do. Like we'll be able to use this library is going to allow us to be able to interact with our smart contract, right? And more specifically, the smart contract ABI, and I think that's application binary interface. And that is a mouthful. So what exactly is an application binary interface? Okay. Long story short, this contract ABI, it pretty much allows us to be able to interact with our smart contract, like, with our front end, right? You can think of it essentially like an API. So it's kind of like that intermediary between like our actual smart contract and, what we'll want to be using in the front end. So, so that's what the contract ABI is, right? Our smart contract ABI. Also, it allows us to connect to our Ethereum nodes. So things like Infura or MetaMask is what we'll be using. I know a lot of people here aren't familiar with that, but MetaMask is a wallet that we'll be using and we'll be installing, and some other things as well. And last but not least, we have React. Now, you don't have to worry much about this. We'll be doing more JavaScript, more so than React. So if you take a look here, even throughout the course of this presentation, you'll see that we have a lot of pseudocode, a lot of things React-wise is already filled out for us. We may just be using some, small things like React hooks to set some things and, just some variables and whatnot. But aside from that, you don't have to be you don't really have to know a crazy amount of React, to be honest with you, or really any at all. So no worries. All right. So these are going to be the three main packages that we'll be using throughout the course of this presentation. So the very first thing we are going to do is we are going to go ahead and, npm install is working. Lovely. Awesome. Let's see. Quickly. All right. So npm install is working. Perfect. So the very first thing we're going to do now is inside our start folder, we have this contracts folder, right? And inside this contracts folder, we'll see something called greeter.sol. So the .sol or sol is Solidity, right? And this right here is essentially where our smart contracts are held, right? So if you ever want to create a different smart contract, right, what you would name it is, let's just call it, I don't know, let's call it Austin.sol, right? If you want to create a smart contract to interact with me, I mean, not necessarily like that, but yes, you would essentially create smart contracts in that manner, okay? And then as you can see here, we'll start from the very top and work our way down. So at the very top, we have Pragma Solidity. Now this right here allows us to, it identifies what version of Solidity we're on, right? Just like with any framework or any library, there's a lot of different versioning, and different versions come with, improvements and sometimes breaking changes, okay? But this right here is telling telling us, but also our compiler or whatnot, that's saying, hey, you know what, we're using Solidity 0.8.4, okay? And then right here, we're importing hardhat console.sol. But this is where the meat and potatoes, this is where we're really going to be looking at, okay, over the course of just, as I said, looking at this contract. So right here, what we've done in our Solidity file is that this has actually been generated. So I want to make this very clear. I went ahead and used like the NPM, using something different called, as I said, using hardhat. So this is actually already generated for us. I'm not a genius with smart contract development, so but I do use it every now. I do a bit of it. So but what we have here is a contract called Greeter, right? And inside this contract that we have, that's called Greeter, is we want to set a string called greeting, and we set it to private, right? And the reason why you want to set a lot of your strings and a lot of things inside a contract to private is because you only really want things within this contract to modify, let's say, your strings or anything specifically for security purposes. I don't think it would be great if you're able to have very sensitive information, be able to have, like, for it to be able to be interacted with, if you were to, like, let's say, have a different contract inherited, or if you extend off of this. Okay. So essentially what this string private greeting is saying is that saying, especially with private, with the private, it can only be changed and modified within the interactions, like within this contract. So we're only able to work with this with anything inside this contract. So let's actually dive a little bit further down, right? Under this, we have our constructor. Well, long story short, this is how we're declaring our greeting variable. Okay. So that's that right there. And, under this as well, as we have this function called greet. Now, this right here, all it's really doing is just returning what our string currently is, right? So it's returning the greeting string. So if I have in our greeting string hi, if we ever call this function, it will return the string, as I said, it will return the, our greeting, right? So if I call it hi, it'll return hi if we called our greet function. And then under this as well, we also have the set greeting, right? And this right here is going to allow us to be able to update our greeting message. And we'll be able to use this set greeting actually within our application, within our React application, which will be really interesting. You're like, how do we interact as Solidity in our smart contract with our front end? Like, that's got to be awkward. And you're kind of right. It really was at first, but it's really fun and you'll enjoy this. Okay. So we'll be using this to actually update our greeting message by using an input field and the submission, a submit button on the front end. Okay. So now that we have that situated, if we have extra time, I might try to actually, we may actually be able to write a smart contract, a different smart contract function for like sending money. But for now, does anyone have any questions about like Solidity or how any of this works?
So if you don't mind, and I might be opening a can of worms here, it's like, what is the purpose behind what we're trying to do? Like what's kind of, I guess, the overarching idea or goal?
Yes. So the overarching, like the idea or goal of this, and let me actually go ahead and show you. So let's see here. I can actually show you if you'd like to. I can actually show you all the finished product real quick. If
sure.
that works. So let me go ahead and show you. Okay. So I probably should have started off with that. So let's go ahead and take a look here. Okay. What we'll do is I'm going to also have to set this main content just for the main sake of things. We're going to set this to false. It's not loading. Let's go ahead and refresh and it should. Let's see here. Oh, wait, it's not loading, but let's set here. Long story short, what we should be able to do is that we'll have our main content and we'll have our error content. What we'll be able to do here is, let me see real quick. Set loading should, it's probably because of the detected Ethereum provider. Let's just go ahead and, boop, or better yet, let's do this. Literally, whoops. Do this momentarily. Should set this to false and it should be bueno. Come on, there we go. Okay, and it's loading and it's loading. I probably forgot to actually set the loading also to false provider. And oh yeah, setting loading to false might actually help as well too. So, but long story short, what we'll do, it is false. I'll just set this to, my apologies. I probably should have actually came through with this and actually had this ready, but long story short, we'll just set this to true or something like that. Let's see here. That should, there it is. All right, there we go. Cool. Yeah, it's a Boolean. Duh. Yes. Yeah. So long story short, we'll have this greeting BAP, and let me zoom in real quick. Can you see that? We'll be able to fetch a greeting, all right, from our smart contract, right? Using, and by that, utilizing our smart contract API, we'll be able to update that by saying updating greeting, and then we'll be able to then update the greeting, right? And so this within our, as I said, then if we do fetch again, we'll then be able to update this, and we'll be utilizing our, as I said, our smart contract, our functions essentially that we built, that have been built out within the smart contract to do so. And this is important because when building out UIs and whatnot, you want to be utilizing smart contracts and there's things like this to help really delegate and essentially, as I said, essentially establishing safe practices, essentially not being able to have the end user modifying for security purposes when interacting with anything in the blockchain ecosystem, to sort of delegate a lot of that, I guess you could say, logic or not, that logic or whatnot, just for just safety perspective. Long story short, but yeah, we'll just be utilizing this and building out a very simple decentralized app doing so. And I don't think we'll be able to deploy to the Ethereum blockchain network. I don't know if we'll have time for that, but I will try to see if we can.
Sorry. Do you mind defining the decentralized aspect a little more? Does that mean that it's like not running on a server instead of running on people's computers or something?
So yeah. So the whole decentralized app, so I guess more than anything or whatnot is that we're going to be using the Ethereum network essentially. So when we deploy this, we'll actually be using, whenever we're making transactions, anything like that, a lot of this is going to be within the Ethereum network. So what we'll see actually is that once we install the MetaMask app or whatnot, it'll actually cost something called gas, right, to be able to to be able to update this contract, right? The idea behind a lot of this is essentially just like within blockchain in general, right? Is the belief is that like, hey, it's going to, just like, hey, we're gonna be able to like send, we'll essentially be able to like update things, we'll be able to work with things and whatnot, and taking the whole idea of like utilizing the Ethereum network to have as a means to be able to use within our application. So connecting with it, being able to send money, being able to update things, being able to, I don't know, should have had a list ready. Create things like tokens, all this different stuff. There's a lot of things you're able to do essentially. So it's just, if that, does that sort of answer it? Not really. Am I kind of, okay, gotcha.
Yeah.
All right, sweet.
I also have one quick question. Like,
Yes.
what benefit will this decentralized app have over the centralized app that we are already using? Like most of the.
So a lot of things are, especially in regards to the decentralized, like this decentralized app world. Are you wanting to interact with anything like a blockchain, right? I think the idea behind this is that a lot of people want to say something like, oh, let's just slap on blockchain, right? Solution, the solution has been found, right? But that's not really the case. In reality, let's say, for example, even like with smart contracts, right? Like I really see a benefit of this primarily within things like the financial sector, right? We find things within the supply chain management sector, right? So in regards to building out a regular app versus a major app, or like a regular app versus a decentralized app, right? One of the biggest things, at least from my opinion or whatnot, is also like the history of like a lot of the transactions that happen, right? So hence the whole blockchain part, because in reality, blockchain in general is just a really, I call it like a dumb database. It's just really just a series of blocks. So everything has like a transaction, everything has a history to it. There's a level of transparency to it. And also on top of that, you can utilize this to also expedite things such as agreements between like two different like parties and whatnot, and having a UI that can help expedite that process helps out substantially. There's a case study I think we did at Microsoft that actually ended up, I think a process that took like months ended up turning into days by utilizing smart contracts and everything like that. But did that sort of answer it? Again,
actually, I understood the financial thing about it, but I may not be able to grasp the concept like greeting thing in what we are trying to achieve in this application. Will that be beneficial to the decentralized apps, this thing that we will be creating?
Yes. So the idea behind this application is to actually bring a level of familiarity with how to use things like, ethers.js, right? These are Ethereum development tools. So being able to interact with the Ethereum network, and then from there you can build up and build like other things and things that you want. So this right here, this tutorial, or at least this like how to or whatnot, is more along the lines of being able to familiarize yourself with how to utilize a lot of the libraries that are used within decentralized app development, more so than anything else. Because so does that sort of clarify things and everything? Are we good? Awesome.
Yeah.
Sweet. Yeah. So yeah, this is more of a familiarity aspect and whatnot, and it's sort of an intro. So I want to try to build out something else, but this is probably the best that I thought that might have been able to do within the given time frame. So now that we have that situated, any other questions at all, which I will be more than happy to answer. No? Yeah, I guess everyone's good. Awesome. Okay, sweet. So now that we've looked at our greeter, like our Solidity contract, right? What we're going to do now is at this point, what we're going to do is we're going to go ahead and compile this contract, right? This contract is done. It's already built. Let's go ahead and compile this, right? And what we're going to do here is, I think for NPM users, just NPM run compile. I have a script that's already set up. Let's see here. Should be right here, or you can just use npx hard hat compile. But I'll do yarn compile. I've already done this, so I don't think for me it'll be nothing to compile. But what you should see actually is if you open up your source folder, you should see this artifacts folder. And inside of this, you should see the contracts. And what we have here, this is our ABI. Now, this is what we'll be utilizing. This is what we'll be importing to, or this is what we'll be using to, and like importing within our project to be able to interact, as I said, as sort of as like that intermediary, like for our smart contract. So again, if you aren't familiar with it, again, smart contract, ABI is essentially an interface that allows us to interact with our smart contract, and we'll be using that for our front end. I kind of think of it like an API, and you'll see why as we actually, once we import it and actually start using it. So now that we've compiled that, right, the next thing that we're going to want to do is we're going to now want to run a local node. So at this point, I have a lot of these scripts built out for everyone. We're going to do a yarn local node. And this right here, what it'll do. So we've just compiled our contract, which is fantastic. Now we're running a local Ethereum node. And at this point, we have a whole bunch of accounts that we're going to be able to use. All right. But there's a problem. Well, how do we use these accounts? And this is where we get into some fun. Okay. What we're going to use now is we're going to use an application, or we're going to use a wallet called MetaMask. So if everyone can, please go to metamask.io, and we're going to go ahead and download this Ethereum wallet. Okay. So install MetaMask. Oh, I guess I already have it installed. I forgot. Oh, that would make sense since I do stuff with it. So you're going to install this. Once this is installed, okay, well, for me, it's welcome back. It's welcome back. We're going to install this wallet. Okay. So can everyone see that? Go to the setup process. It's like creating, I think, as I said, you'll have to memorize you're just copy and paste your mnemonic phrase. Keep that for yourself. Don't let other people know that. It is a secret key. It is called secret key for a reason. It's a secret. You don't want anyone else to sort of know that. So install the extension and go through that process, set up a password. I mean, if you really don't plan on using it, just have a very simple password. Once that's done, does everyone have MetaMask installed?
Austin, can I ask a question?
Yeah, for sure.
So I see that like after you installed MetaMask, it shows something related to cryptocurrency, right? But yes, decentralized apps don't necessarily need to be related to that. Is that right?
Correct. Yes, you were 100% correct. Yes, you were like 200% correct.
Oh, okay, cool. Yeah, this is brand new to me, so I'm trying to understand.
Okay. No, you're 100% correct. Yeah, I think when we think of like decentralization, we automatically think of crypto, like Dogecoin, or Ethereum or Bitcoin and whatnot. But I assure you, I mean, it's just like blockchain in general, right? You don't like, cryptocurrency is just a small aspect of like blockchain. There are other different aspects to it as well. Kind of like how sports to football, blockchain is the cryptocurrency. Okay.
Awesome.
So,
okay.
Yeah, that makes sense. Yeah. Appreciate you asking that. Yes. So now that we have our wallet installed, I mean, yes, you have that. I just kind of did the whole full screen to make it easier. What we're going to do now is we want to use one of these accounts, right? So what we'll do here is we're going to copy this account and copy that private key. Once we copy that private key, we're going to click on this in the top right corner. We're going to click on this and we're going to import account. And then it says paste your private key string here. So we're going to paste that and we're going to go ahead and import. And you don't see anything. And that makes total sense because we are on the Ethereum main network, right? What we're doing now is that we're doing local development. So what we're going to do here is we're going to click over and go to our localhost, which should be 8545. And then now we're rich. Okay. So once you import that account, what you're able to do now is you should see, what is that, 10,000 ETH or 10,000 Ethereum. No, this is not real Ethereum. This is definitely for test related stuff. Okay. So each of these accounts has, I think, what, 10,000 Ethereum. Okay. As you can see here, boom, 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 boom. And there's about roughly 20 of these, I guess 19, oh no, 20 of these. Okay. So we have 20 accounts. We're going to be using this, right? So now that we've imported that, and we'll get to that later. Next up, what we're going to be doing is we're going to open up a different terminal at this point. Okay. And at this point, as I said, bear with me. I'll make sure to step through and I'll explain everything. After this, now that we've compiled the contract, we've, as I said, we've gone ahead and we've set up a node. At this point now, what we're going to do is now we're going to deploy that same contract we just, oh, I'm so sorry. I will take a moment. All right. Sorry about that, Remy.
No worries. Do you mind just showing me where that import button was?
Yeah, for sure.
So let
me go and take a step back. All right. So, and in fact, I'll go ahead and do a quick overview. So we've ran our local Ethereum node, right? And now that we've ran our local Ethereum node, what you'll see is that you'll see a bunch of accounts, account 0, and also private keys. What we're going to do now is we're going to take that private key, right? And this private key allows us to access our account. We're going to, and if you haven't already, install MetaMask. And once you go to the setup and you've installed MetaMask, we're going to go to the top right here. We're going to click this lovely bubble up here, this profile bubble or this My Account bubble. We're going to then go down here to import account, and we're going to paste that private key. All right. And that right there should import this right here. Okay. But also, again, when you've done this, oh wow, look at that. What? Okay. I guess is that. Guess mainnet too. Interesting. That's weird. I don't think that's true. But if it is, what we're going to do now is that we're going to switch the different type of network. We're wanting to do localhost development, so we're switching over to localhost 8545, right? Because this is where we'll be doing a lot of our, as I said, this is where, again, we're running our local node and everything like that. This is what we're going to be working with, okay, on our local developer environment. So now at that point, now that we've imported this, is everyone with me? Okay. Now that we've done this, right, we went ahead, we've deployed our contract. Our contract has now created this interface that allows our front end, or what we're building on in JavaScript, to then be able to interact with our smart contract that we had, and that's the Solidity smart contract. And that intermediary was called the smart contract ABI, application binary interface. And so that application binary interface, when we did that yarn compile again, that allowed us to be able to essentially have a JSON file that sort of is going to interact, and the way we'll use it is kind of like an API, right? So it's like that intermediary that we'll be able to work with and use in our React side of our application. We then, after that, we ran a node. We've then imported the private key. So it's 8545 is kind of the standard for the most part, or at least that's what I've used. So and then after we've ran our local Ethereum node, we've now imported an account, right? And now at this point, what we're going to do here is we're then going to go ahead, and we've compiled our contract, but let's go ahead and deploy our contract, right? And deploying this will allow us to, it'll as I said, using something called, let's see where it is, this script deploy contract. This deploys our smart contract, and we'll have to take a look at the artifacts folder again. But long story short, let's go ahead and do this. Yarn deploy contract. And again, I apologize for obfuscating a lot of this. I'm condensing, I guess, a bit of a, yes, let's see here, deploy, might help if I actually go inside the start folder. Yarn deploy contract as we open up a different terminal, okay? So keep both of these here. And now we've seen a whole lot of different things. As I said, something else just popped up, right? So this is great. As you can see here, our greeter deployed to this, this address right here, okay? So we've now deployed this. Now this is gonna be very important. Again, just keep that there. Let's go ahead and work with this. All right, so we're gonna keep that there. Now at this point, what we're gonna do here is right now, you're gonna be like, oh my gosh, a third terminal. I hope everyone's computer isn't like screaming. We're gonna open up another one, or the DJ Khaled of terminals right now. We're gonna open up one more terminal. Okay, so this first terminal is what's allowing us to run our local. I feel so bad right now. Someone has like 8 gigs of RAM. I'm so sorry. This first one on the left that we have here is for our local Ethereum node. The second one that we have here is what our greeter contract, as I said, or what our greeter contract, smart contract was deployed to. And we'll be using this address in a bit, right? And then last but not least, what I want to do here is I want to actually go ahead and do a yarn start, okay? And let me make sure I'm inside the start folder again. And we're gonna do a yarn start. So this yarn start, I promise you, okay, this is what a lot of people use, okay? Now this is for our front end, okay? Now we're getting to the fun stuff. And at this point, now that this localhost, let's see if it'll, there it is. From all this fun stuff that's happening right now, okay? Now at this point, this is where the fun actually begins, all right? Half the battle was setting all this, going through all of that. Now the fun part is the front end. This is our UI part. So starting off this, right, is we kind of want to like better understand, like how are we building out a UI, right? When we're building out a decentralized app, like, what goes into a UI? Well, first off, what we always need to do whenever we're building out a UI is, well, for one, we're going to be using Ethers.js, as I stated before. Oops, scrolling up here. And as you see, that's already imported. We're going to be utilizing Ethers.js as a means to interact with our smart contract and a lot of other things as well. But the very first thing we always want to check for, and I'll show you all this right now, is that if we go into our console, and let me go ahead and zoom in on this, as you'll see, is after we installed MetaMask, we have something called the Ethereum window object. So if we ever do window.ethereum, we now have this new object in our browser, right? And if we take a look inside of this, we have a whole lot of different functions, right? So this right here can be very important, and we'll look at it. As I said, is MetaMask true? A lot of different things, right? We can see things like the chain ID. We can see things like all these different functions that we can use, but we will not be using because that is a little bit overwhelming. But the first thing we want to check for, right, is to say, hey, you know what? Yes, this is loading, but the first thing we want to really check for inside our application is we want to try to find the provider, the Ethereum provider. What is providing our window.ethereum object? And that happens to be MetaMask. But we want to see if the window.ethereum object is there. All right. So the first thing we want to do is we could just do an if statement that says, hey, if window at Ethereum provider. We could do that, right? But we kind of want to use that provider later on down our application. So what we're going to do here is the first thing we want to do is detect the provider. So we're going to create a variable called const detected or detect provider or detected provider. And then we're going to create a new instance of ethers. So we're going to do ethers, new ethers.providers. As I said, we're going to look at they call it the Web3 Web3 provider, right? So we want to see what is providing the window.ethereum object, and I kind of put any there because I don't really care. So let's see here. I forgot what is the any part. I forgot what I did for the any part, but essentially, I think it's for the network. So we don't really care what type of like network it's on, like mainnet or anything like that. But right here, what we have here is we're going to check for the detected provider, right? So if we detect some sort of Ethereum, if we detect the window.ethereum object, it is now within that detected provider variable. All right, I'm just going to go through this because I know everyone wants a network and everyone wants to talk to people, and talking to people is fun. So yeah, what we'll do here is then, as I said, we're going to try this. So we want to check the Ethereum provider, right? And how do we do that? We want to check to see if it's available. We do that by seeing if there's a window.ethereum object there, right? So we're using ethers, right? The Ethereum, this Ethereum JS, like this Ethereum library, to say, hey, are there providers inside those providers? Like, is there a Web3 provider, right? And is that Web3 provider like window.ethereum, right? And we don't really care about the network. So we can actually remove that if you want, because that's a little bit confusing. But we just want to see if there's a Web3 provider, which is essentially the new way we interact with things and whatnot. So the whole the whole decentralization thing. We want to see if there's a window.ethereum object. So as I said, we set it to that, and we're going to try this. Now we put this inside a try catch because if there is an error, we'll be able to catch it and we'll be able to, log that error. But at this point, what we're going to do is that once that is detected, we're going to set the loading to false. All right. So essentially what y'all saw earlier is you see how our app is loading, right? So it's going to wait until we find that window.ethereum object. Now, once we find that, once that's done, we're going to set our set loading, because it is loading right now. It's currently set to true. We want to set that to false. And then after that, what we'll do is we'll then set the, let's see, provider to detected provider, right? So now we're going to be able to pass this through, which is nice. Now, if there is a problem, we'll set loading to false. And then we'll also set a provider to true, or sorry, false. And then if you want to, you can console.error it.error, and we can do the error dot, I think what message should be the thing. So we have this, don't have to do the console error, but yeah, we'll do that, right? So what we're doing here is we created a function called checking for the Ethereum provider, right? So we're checking for that window.ethereum object. If it's there, what we're going to do here is that we're going to set loading to false, and we're also going to set that provider variable that we have here in React, which is our hook. We're going to set that to the detected provider, the provider that we detected, right? Now, if there's obviously if there's a problem, if there's an error, we're going to set loading to false. We're going to set provider to false as well too. And then what will happen is we'll then have a different error page stating that, hey, you need to download MetaMask, right? That's where, if we take a look at this, if it's false, we'll then show that error content. But since it's true now, what we'll do here is we're going to go ahead. Let me refresh this. All right. Okay. Sweet. Now that we've done that, we're going to go ahead and hop in, and this is sort of just the loading, right? We're going to see if it's loading. If it's loading, we have the spinner here, right? And it also says loading, what we saw earlier. But if it's not, then hey, we're going to go ahead and render this right here. Now that we've rendered this inside this, we're going to say, hey, is there a provider? Well, by default, it's kind of empty, right? So, but if there is a provider, right? If there's a window.ethereum provider, we're going to go ahead and, as I said, we're going to render this main content, this component here called main content, and we're going to pass that provider through. Okay. If there isn't a provider, we're just going to have this error content here. And if you don't know what that looks like, again, I'll set this to false and I'll show you. It'll ask you to download MetaMask. So, hey, you need a Web3 browser like MetaMask to use the site and manage cryptocurrencies. This is the whole thing, right? Let's see here. So I'm going to go ahead and save that. That's what it looks like. That'll pop up. But hey, we're here now, right? And we take a look at this. We have the greeting DApp. Now, time to dive into this main content. So once we dive into here, what you'll see is inside this index.js. So what we're doing here is that we're going inside source, components. We're looking at the folder called made content, and then we're going inside the index.js. Now at this point, we have a provider. We now know that it is not loading. We now have a provider. What are we going to do now inside this main content? Well, the first thing we want to do is at this point is, well, first off, let's just go ahead and get this out the way. We've passed our provider in. That's cool. But let's go ahead and get that greeter contract address. So as you remember here in that lovely middle terminal, out of our 3 terminals, we have the greeter deployed to this address right here. We're going to copy that and we're going to put that here, right? So we have to grab that contract address essentially, right? Because that's where that's been deployed to, right? And this will all come full circle. I promise you, you'll be like, okay, this is making a lot more sense now. But for now, we've done that. Now that we've done that, okay, the greeter contract address, what we're going to do here is that the very first thing we want to do, right, now that we have this provider, well, we want to go ahead and, as I said, we're going to be utilizing MetaMask to sort of, interact with our decentralized app in a sense. So we want to connect our wallet or our app to our wallet, or wallet to our app, vice versa, however you want to look at it, right? So what we're going to do here is I'm actually going to go to docs.metamask.io. I don't remember things a lot. I know where to find things, but as an engineer, that is very important. And I'm just going to go inside this getting started. Like I don't know what I'm doing, It didn't help out. So let's see here. And you know that Ethereum object that we talked about, right? Well, inside this Ethereum object, we have something called request. So window.ethereum.request. Well, what do we want to request, right? We want to connect our application to we want to request like connecting our ETH, we're sending a request to connect our accounts, right? So we have something, and we'll do this real quick. We want to do exactly that. So we want to connect our app, our app that we're building out to our wallet. And what we're going to do here is we're going to go ahead and let's see here. What is it? We're going to do a const. We're going to create a const. We're going to call it requested account, right? So what we're essentially doing is we're wanting to say, hey, you know what we're going to do is that we want to go ahead and request our account. That account that we imported, we want to request the ability to be able to interact with that, right? We have all this ETH because, we have all this Ethereum. We want to be able to do things. We want to be able to send things. We want to be able to, as I said, create some sort of transaction, right? So like whenever we update the greeting, we want to go ahead and send that request. We want to update the greeting. And then it's going to cost Ethereum, and our wallet has Ethereum. So we're going to want ahead and we're going to want to go ahead and connect and request a connection to our account. So we're going to do request account or requested account equals await. This is an async function. And we're doing, let's see here, Ethereum.request method ETH request accounts. Although it only supports, I think, one account, which is weird. Future proofing maybe. Request. What do we want to request? We're going to use this method called ETH_request accounts. And as we do that, let's see here. Whoops. We will do this, and we're going to save this. What we're going to do here is greeting contract address, related to wallet. No, it's not actually. So what this is related to our Solidity contract. So I probably should have drawn some sort of diagram to help things move along a bit better. And I apologize. Essentially what's happening is our app is going to connect to our wallet essentially to be able to do the whole transaction part of things, right? But again, we'll be also importing our greeter.json, which is what we have up here, right? To sort of call those functions that we built out for our Solidity contract. So I'll show you as we continue. And I know this is a lot to really take in. Let's see here. So after this, what we're going to do is once we get that requested account, we're going to say, hey, if there is a requested account, right? If let's see here. If there's a requested account, we want to go ahead and get the first one, and we're going to see if hey, does it have a link? Right. So if it does have a link, right? If there is one, essentially, if there is one, what we'll do here is that we're going to set that account that we could use, and we'll use this for other things if you want to. I kind of put this out here for y'all to play with, more so than me. We're going to return. All right. Oh gosh, let's see here. Boop. Set requested account. There it is. Boom. Okay. And then if there is a problem, we're going to do something like I think throw new. We're going to throw an error. So let's say, for example, someone decided to reject this, and this will sort of make more sense as we build out the whole fetch function, and I'll show y'all how this works. But essentially what we're doing here is we're saying, hey, you know what we're going to do here is that we're building out a function that is wanting to request access to our MetaMask wallet, right? So we use that using the Ethereum.request method. All right. And this right here, this ETH request accounts, you can take a look here at the, essentially what'll happen is that I'll go ahead and click this right now. We can take a look. A pending promise request saying, hey, you know what, just like with this right here, we want to go ahead and we want to, we want to request access to be able to interact with our wallet that we have imported. Okay. And so, well, now at that point, it'll say, hey, do you want to connect? Yes. Are you sure you want to connect? And you'll be able to connect. And now at this point, this is where we'll be able to use our wallet to interact and do some things as well. Okay. So does that sort of make sense? All right. Got you. Okay. Again, I also have resources at the end of this. So I'm not the only source of truth here. I assure you. Then afterwards, right? So we've requested that account, say, hey, if they happen to say, do the whole confirmation, they go through that flow, we want to go ahead and set that, the requested account to our variable up here. We're just going to return. We're done, right? Now, if they do happen to deny it, right, that means that, well, we didn't really get an account, and then we're going to throw an error, okay? So at that point, that's nice. Now, at this point, what we want to do is this will become very useful when we do the whole update our greeting, but under fetch greeting, right? Now, this part right here is what we're doing is that we're actually going to be trying to use this whole greet function that we have in our Solidity contract. So in our contract, we set a greeting, we set a greeting and we have a greeting function. How do we use that greeting function that we have in our smart contract within our front end? So the first thing we're going to do here is, does anyone have any questions so far? And is everyone following? Are people lost? Be honest.
Can I confirm one thought?
Yes.
And I might be totally out to lunch. Are we effectively using Ethereum as an event sourcing tool
Yes.
for building up the greeting? So the latest state is basically the last result of whatever we did to the chain.
Yeah. So essentially, request accounts. We'll actually use that within our update greeting or whatnot, because we're gonna have to send the account as well. Like we're gonna have to send the individual who, as I said, we're gonna have to send the account to update the greeting. Like, oh, like who's updating this, like this greeting, right? I feel like I should have done something like a basic financial app or something like that to probably be a bit better now that I think about this. But long story short, though, we'll see that within the updated greeting, because usually everything, whenever you send a transaction, there has to be some sort of signer. There has to be someone who is like, oh, this is coming from, like there's a to and a from address, right? So, who is sending this? It's just like when you send a piece of, like when you send an email, right? You are the, there's a recipient. There's also the individual who's just sending it, like the to address, that whole thing, right? So you have to have that. There has to be some sort of like signature, and individuals say, oh, well, hey, I'm the one who's actually like sending this this information or whatever it is, right? So there's a level of validity behind each transaction, right? So as I said, we've requested the accounts. We're saying, hey, now that our app is connected, whenever we send, let's say, whenever we update the greeting, our account name that we have that we're using for our wallet is now officially within that, is going to be used within that signature, right? So when we send that out, if that makes sense. Now at this point, what we're doing is we can go ahead, and now that we've done that, we're going to just go ahead and try to fetch the greeting, right? So whenever we click this fetch greeting function, we want to just go ahead and see, like, hey, what exactly is the greeting, right? Within our, that we have. And to essentially do that, what we're doing is we're going to go ahead and say, hey, for fetch the greeting, what do we need to do? Well, first off, we need to use ethers to call the contract abstraction, which is that contract, like that whole ABI, right? We're going to use the greeter.abi for this. So we're going to create a constant called contract, or variable called contract. And we're going to use ethers dot contract, right? So at this point, what we're going to do here is that in the contract, there are several different things. So there is what we're going to be using is we're going to be using the greeter's contract address. And then here is that we're going to be using the greeter.abi. Let's see here. I want to say where is it? Greeter.abi, right? So because we've imported that, right? We've imported this greeter, which is this, this old JSON file. We're using the greeter.abi. And then from here, we're then going to pass the provider, which is the window.ethereum, object essentially. And then from here, what we'll do is that we'll then go through and we'll actually get that contract data. So what we need to do now is we need to call the greet function from the contract and grab that data. So how do we do that? We're going to create a variable called contract data. And we're going to wait until we get that contract we're going to wait till we get the information, that data from the contract greet function. Okay. And then from there, what we'll do here is after we get that information, what we want to do now is that we want to update the text on the page to show the contract data via the set text call. So what we'll do here is that I kind of have something down here that'll actually display the text that we have. So we'll just do something called set text. We have a variable called text. To be able to update that text, we're going to call a React hook called set text, and we're going to do a contract greeting message, and we're going to do, let's see here, what is it? And then we're going to pass through the contract data, right? So this is a whole lot. And also, we're going to also just set if there's an error, we're just going to also log that error message. So let's go ahead and save this and let's just take a look, because that was a whole lot to really go through. So how in the heck did we get this? Let's go ahead and take a step back and let's take a look. Okay. So, disregarding this, right? Because we didn't need to access this. What we wanted to do is that we wanted to say, hey, we have a contract, right? I wanted to go ahead and fetch that greeting, like the greeting that we have inside our contract. So how in the heck did that happen, right? So we use ethers to call, or essentially to sort of generate or craft a contract. Oh gosh, I should know this. I do dApp development all the time. We essentially create a new instance of a contract, right? So what we're doing here is that we grab that greeter's contract address, like, hey, where's this contract deployed to? It's deployed to, this address right here, right? Okay, cool. It's deployed that. Let's go ahead and take a look. Now we have that. You remember how we compiled that contract and we got the greeter.abi, that application binary interface? And that right there, as I stated, is what we'll be utilizing for, let me see real quick. Where's that at? This .json, right? So we have this greeter.json, right? And we've imported that as greeter. Well, from that greeter.json, we want to go ahead and use this greeter.abi, right? And we did exactly that, the application binary interface. Now, if we scroll through this and we take a look, there's a lot of things in this, right? So there's everything from, oh, hey, there's, as I said, we have a function. We have a lot of different things, right? So we have this, let's take a look here. We have this, let's see here. Let's go ahead and we have this set greeting function, right? We have where's that greet function? We have our greet function, okay? And so what we're doing here is we're essentially taking this, as I said, this is sort of that intermediary, right? Intermediary, my goodness. And we're calling that that greeter.application binary interface, right? And we're also saying, hey, now that we have that greeter contract address, we have the greeter.application binary interface and provider. Now let's go ahead and try to create some sort of a type of so just work with this, right? We want to create some sort of contract or something that we can interact with on the front end. So hence our contract. So it does all this stuff and, makes it nice and usable for us on the front end to be able to call a lot of the functions that we have on that. So if I wanted to do contract.set, I think it is set greeting message, correct? Yeah, or set greeting, actually. I think set greeting, we can call that function as well, right? Because again, it compiled, as I said, it compiled all this. Once we compiled it, then created this interface, and this interface is what we're using to import and use to interact, with our front end, essentially. Oh, there it is, within our front end. So what we're doing now is that inside that contract, what we're doing is that we're calling the greet function, okay? So again, that's there. And if we click this, we now have that contract data, right? And then from there, what we've done is that we've created a way for us to display that text. So what exactly the contract greeting message is, contract is, as I said, it'll display the contract data, and that contract data is hello, hard hat, right? So is everyone following me here at this point? Now, if there ever isn't, okay, if there's ever an error message, we'll then just say, hey, you know what? Let's go ahead and display that error message that we have. So now that we've been able to fetch the greeting, right, from our smart contract, we've been able to fetch this greeting. Now, this is where a lot of the things I talked about earlier, from being able to request and being able to connect to an account, and all this is really going to be coming into play. All right. So we have this input field here, right? If we want to update a greeting, we kind of have to type something. So we're going to do something like testing. And then when we click this should actually go ahead and we should be able to update our greeting. So that obviously, as we do this now, definitely isn't going to work. In fact, I think if I press this, it's definitely going to error out. Oh, and it's doing an error out. It's just not going to, nothing's going to happen. Okay. So what we're going to do here is we want to use it. We want to have a function on our front end. So whenever we click this button here, right, on click, call this update greeting function. So what do we want to do, right? Well, what we're going to do here is the very first thing is we want to get the signer, right? So what exactly is a signer? And that should be in the MetaMask docs. I should have put that in there. I did not put that in there. Okay, never mind. Signer is essentially the individual who's going to be signing the message, right? So when we send this updated testing, we're going to be passing it a signer, and that signer should be the individual, as I said, who is, essentially like us. It should be us. So what we're going to do here is, because every message that we send in a blockchain, it usually has to be signed. There has to be some sort of signature with it, right? Just like whenever you whenever you deposited, trying to think here, whenever you send an email or anything like that, there's always someone who's signed the message, or there should be an individual who you can always point back to, essentially. So signer equals provider. So inside of provider, we're going to use the get signer method. Okay. And then from there, what we're going to do is that we're going to say, hey, what we're going to do now? We're going to grab the contract at this point, and we're going to pass that signer through, right? So const, I guess I'll call it contract with signer equals new instance. So ethers, we're going to create a contract again, and then we're going to pass it that contract address. We're then going to pass it the greeter.abi, right? That was what we used to interact with our smart contract. And then the last but not least, instead of the provider, we're going to actually pass it the signer, right? So, I mean, this right here, right? So we're going to pass this in. Then after that, what we want to do here, we want to set the greeting via the set greeting function in the contract is what we had. So how we're able to, if we look up here, we're able to use, after we got the contract, and once that's been constructed, we use the contract.greet function, right? Here, what do you think we're going to be using? Anyone have like an idea? I believe in you. Si se puede. You can do it. No? Okay. All right. Well, we're going to be passing the set greeting function. So how we call that .greet function, we're actually going to go into the set greet function. Yes. So I'll call this the this is actually the transaction part, but we'll just call this the let's see here. We'll call this the I guess I'll call it the transaction equals await, and then we're gonna we're gonna pass that contract with signer that we have, and then we're gonna call that set greeting function that we have, and then within that, what we're gonna do now is that we're gonna pass the greeting that we have, right? So at this point, that's what we should be passing, and then from there, let's see, wait for the transaction to be confirmed using .wait. We'll do exactly that. So what we're going to do here is that once this is sent right into the the set greeting, once this is sent out, we're going to have to wait for it to be confirmed. So we're going to do an await transaction dot wait, and once this is confirmed, what we'll do is at the end of this, we'll then fetch that new greeting. So we'll call that fetch greeting function. Right into that. And then if there is an error, as usual, let's go ahead and log that error. Set text. And we're going to just log that error dot message if there ever is something that's wrong. So if we save this and we take a look, we've now, I'll just refresh, right? We fetch the greeting. Let's say if we want to update this greeting, test, right? We're going to click updating the greeting. Oh, okay. Oh, we did something fun. Oh, that's what we forgot to do. We forgot to request the accounts. We forgot to actually do this. Await request accounts. And so if we refresh this, we fetch it. All right, cool. You know, let's go and test this, testing. And then we click update. What this will do now is that, hey, you know what? We want to connect our, we want to connect our wallet to this. Sweet. Once we connect this, we've now created a, we've now created, as I said, something that we want to, we want to now call the set greeting function that we have here, right? So we've created a transaction. So what we're doing here is for sending this up to update the greeting that we have via the set greeting function, it's going to cost us money, which kind of stinks. But hey, you know, we're kind of rich. We have 10,000 ETH. And we're now going to be able to say, hey, you know what? Call this estimated gas fee. It's going to be this. And we're going to go and confirm, right? So now that's confirmed. As we can see here, now we should see the contract greeting message being updated to testing. Oh, what's the cost for the transaction? Oh yeah, so that should be variable. It's based upon the network, but as I said, like gas prices is sort of like are variable. So could cost a lot, could not cost a lot. That's sort of set automatically. But it should be really cheap since we're doing it locally essentially. If it's on the Ethereum mainnet, you know, good luck. It could cost $50. I don't know, but yeah, you know, stuff like that can happen. So, but essentially, since we're doing this locally, again, like this is just more than anything right now. Again, this was just sort of a means to be able to get familiar with how we sort of interact with contracts within the Ethereum ecosystem, but also on top of that, you know, how do we use this library called ethers.js, right? For us to be able to generate and use our contracts that we compiled locally. And, you know, as I said, and call those functions off of that as well too, right? And not only on top of that, but also using our the Ethereum global object as well too to say, hey, you know what if we want to connect our application to something? If we want to build out an application that does something like trading, oh, what if we want to, I don't know, build it out for just about almost anything or everything. But essentially, this is just sort of a means to be familiar, or at least become familiar with, as I said, how to sort of build out a DApp or decentralized app. Yeah. So that pretty much is the presentation. Let's see, web server, while the contracts with smart contract apps are on the blockchain to be called using an address. Yeah, I would love to deploy this for y'all, but I think that takes about a good other like 5-10 minutes, and I kind of don't want to be that person. So like deploying that on the mainnet, which is really fun to look at, by the way, and really cool to do. But yeah, we'll just leave it as is for the time being. But essentially, that's what it was. Anyone have any questions at all?
I have a couple questions queued up here, Austin, if you don't mind answering them. Mm-hmm. So Kevin has a question. He says, hey, Austin, just wondering what your take is on serverless versus decentralized apps. I hear these terms used often in the dev world, and just wondering what your take is on this.
Serverless versus decentralized apps. I mean, it's weird calling it serverless because, you know, you're still using the server. I'm never really, but I get the concept. I mean, again, I think more than anything is that when we look at anything, not only just from decentralized apps, but also blockchain in general, the first thing I always want to look at is what problem are you trying to solve, right? You know, I could say like, oh yes, use serverless, or oh yes, use, you know, this or that, right? But in reality, what is the problem that you're trying to solve? And yes, Ethereum, or, you know, creating a decentralized app could solve it, but should it, right? And so that's sort of what I should sort of get with that, like, you know, choosing either or. That's more of a per application, like sort of a use case, I have to say, but also even more so, you know, as I said, again, we have to deploy our UI, our user interface, like our UI somewhere, right? So yeah, so I mean, it has to be deployed to a server somewhere, like we have to deploy our React application somewhere in order for it to interact with that, you know, smart contract. So which also has to be deployed. So any other questions? Did I answer it? No, my take on it. I mean, you could use both essentially, I guess, but.
Next, what we have is, where's the cost for the transaction set? I don't see it in the code. Is this a set amount for every transaction?
Yeah, so you can actually edit that. There's usually like a default cost. So there's like the more you pay, the quicker your transaction sort of gets prioritized on the blockchain. So specifically for this though, it's like localhost. So the transaction cost is, I mean, inherently low because I mean you're running your own like sort of like node, you know, your Ethereum node. So you know, again, like the cost is sort of there's not like a set cost per se. You know, when you deploy it, you know, I guess when you deploy and you start doing transactions on like the actual Ethereum like mainnet, that's when things start getting quite variable, you know, up. Yeah. So, you know, things can cost more, things can cost less or whatnot, but that's not set within the code. You can, I think, if I'm not mistaken, have a means of being able to set sort of like a default transaction cost, but for the most part, that's determined based upon the congestion within like a network. And obviously it was like really low because I don't think there's a lot of people running your app on your local host other than you and all that stuff. So
if you don't mind me following up, then I guess I was sort of conflating two different prices. And so if you wanted to create a transaction where you were actually transferring money, that would be a different maybe set value that you set in your function, right? Whereas this is the cost purely of the transaction. Yeah.
Yeah. So yeah, if you want to send money or whatnot, yeah, correct. Yeah. So if I actually want to send money, let's say if I want to send like 50 Ethereum to like you know, my first account that I have, right? We have two accounts. I imported one. If I want to send that, right? That right there, that's like the actual, that's like what I'm wanting to actually send. And then the next part, in fact, let me go ahead and do this. So I'll send this, transfer between accounts. I guess I'll just go here. And I'll say, hey, I want to send my other account 50 Ethereum. This is actually something called gas. So yeah, gas fees, if you take a look here, are paid to crypto miners who process the transaction on the network. So it essentially costs to get this transaction sort of processed to the blockchain, right? So there's a fee associated with that. So whenever you send some sort of transaction, there's always a fee to be had. So, you know, nothing is, yeah, is free. So if you want to have a, I'm trying to think here, there's a whole thing about, yeah, high, all this different stuff. Yeah, there's a high, medium, low. If you want your transaction to be completed a lot quicker, because it's not instantaneous, right? You know, you just set a higher gas price, like saying, hey, you know, I'll pay you more if you can process this quicker. It's kind of like that in a sense. Yeah. Oh, okay. There. Does that sort of make sense? So these are two like different things. Does that answer it? Awesome. Sweet.
Awesome.
Another question?
Okay. And the last question we have here is, where will the data be stored if deployed?
So you can actually take a look at, there's like actual contracts will actually be deployed onto the Ethereum like network. So you can actually deploy this deploy it to like the Ethereum mainnet, and it'll actually be deployed like on the actual like legitimate like the blockchain, the Ethereum blockchain, like the actual Ethereum like blockchain. So hence why people call it the Ethereum mainnet. So yeah, does that sort of make sense? It's kind of weird. It sounds really weird. And it's like, it's going to be stored in Ethereum. Like, wait, what? Like, it sounds really, yeah, but yeah. So if you want to create their own blockchain used for secure transactions. Yeah. And there's different types of, I'm sorry, I'm looking at Brock, what Brock stated. Yeah. Like there's different types of blockchains and different types of things. There's like privatized blockchains, there's, you know, public blockchains. There's a lot of different types of things. Right. So for example, like I know, for you know, let's say if you're settling insurance claims, right? Let's say you decided to create some sort of smart contract for that. Now, granted, you don't need to really pay money for that, but essentially, like again, you don't want to have people on Ethereum like know that you're settling, you know, smart. All that sensitive data is there, right? So I mean, you can have like private blockchains and things like that within companies. Yeah. So secure transaction or secure data or whatnot, that all is like a per use case basis. There's things like R3, Corda, and all this different stuff that you're able to use. Yeah, I know. I'm like spitting things out here.
That's awesome. All right, I think that's it for questions. Other than that, I just want to give a huge thanks to Austin for that wonderful presentation. Thank you so much. That was amazing. So thank you for your time and everything.
Thank you. Yeah, I have little things to improve. I'll skip that. Resources, I'll just have that for the recording. If y'all want to just take a look at that, pause 2 seconds. Boom, things improved. There's a lot of things we could have improved on this. Resources, I was going to try to create a longer resource list, You can go to like the docs.metamask.io. There's a whole tutorial. There's also actually Nader DeBit created, he did something very similar, ironically enough. He actually was what got me into like using Hardhat. He does an even better job, in my opinion, explaining it. And I recommend you check him out. There's a lot of other things out there. Stephen Greider has a smart, blockchain, Ethereum blockchain course. Feel free to check that out on Udemy as well too. But there's a lot of different resources. So yeah, check that out. Let's connect. Feel free to follow me on Twitter, tweetmonster999. I did make that in 8th grade, so don't judge me. B-Boy Akers, it's my GitHub. And if you want to add me on LinkedIn, just feel free to add me on LinkedIn. So yeah, we can always talk. So yeah, thank you.
Thank you, Austin. Wonderful presentation. It was fantastic. So thank you so much for being a guest speaker. So hard virtually clapping for people, but this is like a full.
Hey, somebody got the emoji. Hey, they got the emoji. Wait, I want to clap too. Okay, there we go. Okay.
All right, awesome. Thanks for coming, everybody, and have a good night.